Now that we know a little bit more about what's going on underneath the hood of these blockchains, let's go back at our transactions and look at this gas thing again, and we'll look to see what's actually happening here. Gas in particular can be a little bit tricky to wrap your head around, so if you don't get it right away, don't worry. As we go through examples, it'll start to make more sense. So before I was saying, let's just look at this transaction fee bit, which is the cost associated with running this transaction. If I scroll over this on Etherscan, I can see this thing that says block base fee per gas plus max priority fee per gas times the gas used, which might be a little bit confusing here. Let's actually break down what's going on Ethereum with EIP 1559 in place. And again, this is going to be specific to Ethereum, as every blockchain might do it a little bit differently. But if we click to see more, we can see a number of useful values here. We can see gas limit is 21,000 and usage is 21,000. So this transaction used 21,000 gas, and we sent 21,000 gas along with it. Sometimes when sending a transaction, depending on when it's sent and depending on what the specific instructions are, it might actually use way more gas than what you want it to use. So with your transactions, you can actually set a limit. Hey, I don't want to use more than X amount of gas. I don't want to do more than X computational units. And in fact, if we go to our MetaMask and we click send to transfer between accounts again, and we pick, 0.01 ETH or something, next, we can actually hit this little button here, go to advanced, and we can actually edit some specifics of this transaction. One of them is going to be the gas limit. We can change this gas limit to maybe 2,200, 2,300, or more or even less. Since sending Ethereum takes exactly 21,000 gas, MetaMask just defaults to setting it to that. But we also see these other interesting things. We see a priority fee and a max base fee. Let's reject this transaction and let's look back at Etherscan to talk about these. So currently in Ethereum, according to EIP 1559, every transaction on Ethereum comes with something called the base fee. This is the minimum gas price you need to set to include your transaction. And you'll notice that these are priced in something called Gwei. So what is a Gwei? If we come to the site ethconverter.com, and again, there's a link to this in the GitHub repository, we scroll down, we can see Wei, Gwei, and Ether. If I put 1 Ether in here, I can see how much 1 Ether is in terms of Gwei and in terms of Wei. 1 Ether is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 9 zeros. So that's 1 billion Gwei is going to be 1 Ether. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. And then 18 zeros is a Wei. These are just easier ways of referring to really, really small amounts of Ethereum. So if we look at our gas fees, we see that the base fee is 0.0000004 Gwei. And this obviously would be an even smaller number if this was in units of Wei. So if we take this number and we put it into our calculator, we can see that this is equal to 40 Wei, or 0.00000, a whole bunch of zeros for Ether. The max fee here refers to the maximum gas fee that we're willing to pay for this transaction. And you can actually see that our max fee is a little bit higher than what we actually ended up paying. Our max fee was 2.2132 something, and the gas price we actually paid was up here. Now your transaction might, of course, be a little bit different. Then additionally, we have a max priority fee. This is going to be the max gas fee that we're willing to pay, plus the max tip that we're willing to give to miners. Now, currently in Ethereum, this base fee ends up getting burnt. And we can see on Etherscan exactly how much is getting burnt here. And if we pull up our calculator again, we can grab this gas fee, multiply it by the amount of gas we used, and we can see that this is indeed how much Ethereum we actually ended up burning. We go back to Ethereum converter, paste it in, we can see that these two numbers are indeed equal. This means whenever you send a transaction, a little bit of Ethereum is removed from circulation forever, or it's considered burnt. So currently in Ethereum, part of your transaction fee actually gets burnt, and then the other part goes directly to miners. So to figure out exactly how much went to miners, we could do this number minus the burnt amount. And this is how much Ethereum was paid to an Ethereum miner for this transaction. You'll see down here, transaction type 2, EIP 1559. This is the EIP 1559 version of these transactions. Like I said, every blockchain is going to have a different fee burning and fee and gas process, and they're all going to be a little bit different. But the sum of it is blockchains have limited block space for transactions. The gas price that costs for your transaction to be included in one of these blocks changes based off how much demand there is. The base gas fee for Ethereum will go up and down depending on how many people are sending transactions and how many people want to be included in a block. If a ton of people want to be included in a block, that means a ton of gas is obviously going to get burnt. We've left a link to a video in the GitHub repository with this section from this YouTuber who does an amazing job breaking down this EIP 1559 and more about how this gas model actually works. I highly recommend you pause this video and watch that video to understand more. The base fee gets programmatically, algorithmically adjusted to try to target for all the blocks to be 50% full. If they're more than 50% full, this base fee automatically goes up. If they're less than 50% full, this base fee goes down. Now, this is a lot of the basics of how this transaction works, and it can be a little confusing. So let's do a quick refresher of everything in here. There's a unique transaction hash that uniquely identifies this transaction on this blockchain. We can see the status. We can see the block number that it's confirmed on. One other thing we want to look at, if we scroll up, we see block number and block confirmations. This is how many blocks have been mined since this block was included. Like we saw with our blockchain demo, the longer the blockchain gets, the harder it is to tamper with and the more secure it is. Typically, you'll see some processes say they'll only do something after 20 block confirmations, 30 block confirmations, or etc. The reason that they wait for these block confirmations is because they want to make sure that that transaction is actually included. And we can actually see the block that our transaction was included in and all the other transactions with it, different details about how much gas was used, the gas limit, etc. Timestamp is when the transaction happened. We can see from and to, we can see the value, and then we can see the transaction fee, which we see right here is block base fee per gas plus the max priority fee per gas times the gas used. And we see all the details of the gas down here. Gas price is the cost of 1 unit of gas. Gas limit is the max amount of units of gas that we're willing to pay in this transaction. The usage is how many actually got used. The base fee is going to be the base network fee per gas, so 40 Wei per 1 gas used. The max gas is the max gas price we're willing to pay, and max priority is going to be the max gas price plus the tip that we give to miners. And then we can see how much is burnt, and then we see transaction savings, which is the difference between how much was actually used or paid for and then returned. So for example, in this transaction, the gas price we ended up picking was a little less than our max gas price here. So the gas price we ended up using was a little less than our max priority fee here. So we had some savings compared to that. We can also see that this was an EIP 1559 transaction. We can see our nonce here, which was nonce 0 because the transaction that I'm showing is our first nonce. And then of course, we can see the input data. For transactions that are just sending Ethereum, the input data is going to be blank. But you'll see that when we get to smart contracts, the input data is not going to be blank, and it's going to be one of the most important features of these transactions. You'll also notice that there's a state tab. This is an advanced tab, and it shows the different states that are changed based off of this transaction. We're going to ignore this one for now. Now that we know how the blockchain itself works under the hood, let's talk about some blockchain fundamentals. And we actually covered all these topics in a previous FreeCodeCamp video. So let's go to that.